20p squared minus 100p cubed plus 125 q squared. All right, a lot of large numbers, right? But what can we do here? First, okay, greatest common factor. Do we have one? Yeah, we do. We sure do, right? What is it? 5, right? Because 20 is 4 times 5, because 125 is 5 cubed, right? So we know 5. And we can't eliminate p or q, right? So it's just 5. Alright, so that leaves us with 4p squared minus what? 5 divided by 100, what's that? What's left? 20. P cubed plus 25q squared. Okay, and then when you look at it, you should be able to see, all right, I don't have any other common factors. You should be able to look at that again and say, all right, there are no other common factors. And you should check that because sometimes, you know, a lot of times students will factor, but they won't factor high enough. So that's a good idea to check that. Okay, put our parentheses, put our variables, p's, put our q's in there, okay, put our signs. Factors for 4, factors for 25. All right, go ahead and try that. Okay, you see the advantage of having factor tables? Because when you got the factor tables there, you can see the numbers right there, right in front of you. So the answer should jump out at you. What would you use? 2 and 5. Yeah, you got doubles and doubles, right? Anytime you see double, a pair, like a pair of 2s and a pair of 5s, chances are pretty good you have a perfect square trinomial. And you should do those first. 2 and 2, 5 and 5. Check it. Minus 10 PQ, minus 10 PQ again, and we get a minus 20 PQ. And it checks. Okay? You can leave it like that, or you could write it as 5 2p minus 5q parentheses squared. Now the only way you can do that is if these two are exactly the same. If there's anything different, and that includes the signs, if the signs are opposite, cannot do this.
Could you have done that on the last one too?
On the last one, yes you could. You could make this 4p minus 5 parentheses squared. You could do that too. Yes. Okay. Now we're going to get into what we call the difference of two squares, where we have a plus and a minus. Everything else is except for a plus and a minus. Cannot do it for those. But these you can. Okay. So if you get this kind of problem, and the My math lab tells you got to simplify it further, then what you need to do is go to that, okay? But it should take it the other way, but just in case it doesn't, then just go ahead and break it down a little bit further. Okay, any other questions with that? All right. Now we have what we call the difference. Of two squares. Basically, x squared minus y squared equals to x minus y times x plus y. Okay, that's the difference of two squares. So if we were to FOIL it, right, x times x is x squared, and then x, you get plus xy here, and a minus xy here, and then minus y squared. You get back to, these two cancel each other out. The two middle terms cancel each other out. You get back to the x squared minus y squared. And it checks. Okay? Well, that check is real important, because if we have the sum of two squares, let's see what happens there. X squared plus y squared. Well, if we did x plus y times x plus y, right, that would be x squared, right, plus xy, these two inner terms, that would be plus xy, and then the two last terms, that would be plus y squared. We get x squared plus 2xy plus y squared. Well, that doesn't work. Okay? Well, what about x minus y times x plus y? Well, that's going to be x times x is x squared plus xy for the two outer minus xy for the two inner. The two last are minus y squared, and you get the difference. The two middle terms cancel. And you get x squared minus y squared. So that doesn't work either. And so the only thing that's left is x minus y times x minus y. So that's going to be x times x is x squared minus xy, and then two inner, that's minus xy again. Two last is plus y squared. Well, that's going to give you x squared minus 2xy plus y squared. So that doesn't work. So only thing we can say is the sum of two squared is prime. It's a prime factors. Cannot factor something out using whole numbers. You can't factor it out at all. So anytime you see the sum of two squares, automatically that's prime. Okay? Not many homework problems, not many times you're going to see a prime for an answer. And even less for the homework or the test. Alright? So, just let you know that. Alright? Questions?